This week on a special episode of Quality Digest Live, we examine the automation of metrology in a thought-provoking interview that we'll bring you when we come back.
This week's sponsor of Quality Digest Live is 360 Performance Circle, your destination for today's best training tools. Streaming online now.
Welcome back to Quality Digest Live for August 22nd, 2014. QDL is your weekly look at who and what is making the news in the world of quality. I'm Mike Richmond, publisher of Quality Digest. My esteemed colleague Dirk Dusharme is still on vacation. Now, Dirk may not be here this week, but that doesn't mean you won't see his smiling face and hear his insightful commentary. That's because in this episode, we're going to show you an interview that Dirk conducted a few months back at HxGN Live. In this segment, Dirk chats with Angus Taylor, President and CEO of Hexagon Metrology North America, and Paolo Guglielmini, Paolo, Director of Business Development for Hexagon Metrology. The topic is automation for metrology, so take a look.
Welcome to the executive edition of HxGN Live 2014, streaming to you live from the MGM Grand Hotel in Las Vegas, Nevada. I'm Dirk Dusharme, Editor-in-Chief of Quality Digest, and the topic today is what does automation for metrology mean? And in the studio with me right now are Angus Taylor, President and CEO of Hexagon Metrology North America, and Paolo Guglielmini, Vice President of Global Business Development for Hexagon. And Angus, it was what, like maybe a year ago we were here, right?
Absolutely, yeah, exactly 12 months ago this week since we were here talking like this.
And we had a really nice chat. And this time we're going to be talking about, as we said, automation for metrology.
Yeah.
And Paolo, let me start with you. I mean, first of all, let's set the stage. Typically, for most of us, I know for myself, when I think of automation, I think of a discrete piece of equipment doing something automatically, unattended, but Hexagon's got a broader view, right?
Yeah, we do. I mean, we think that automation is extremely relevant to all the manufacturing processes when you're really trying to get productivity, when you want to maximize the use of your assets, when you want to limit energy consumption or limit human intervention to standardized quality. And we obviously believe that when it comes to dimensional inspection, automation is a fantastic opportunity to do exactly that. We want to focus on the manufacturing process itself, on the data acquisition and the data management, and we want to minimize the time that is required for the inspection setup when we want to get inspection as close as possible to the manufacturing process. So it's a fantastic opportunity for us from a hardware setup point of view, metrology setup point of view, but also in order to automate further the data management piece. So.
Okay. And this is all, we'll be getting to this further, I'm sure, but this is all tied into productivity improvements up and down the line, not just in one discrete area, is that right?
Absolutely. That's the end game. This is exactly the end game.
Okay. So why should manufacturers automate all their processes? And by the way, are we talking about just manufacturers, or are we talking about other parts of the industry as well?
Well, there's other parts of the industry, Dirk, but one of the main drivers, I suspect, if you like, for this change is the change in skill sets, the way this has shifted through manufacturing, because manufacturing historically was always took place at the end of the line. We had inspection that was done, but that has changed significantly over the last few years, and whereby this is now dispersed more across the whole manufacturing process. And by doing so, the skill sets that used to be in a different location are now in another location. So therefore, what we need to be able to do is provide tools to make that happen. So it's really a shift that has happened inside of manufacturing, of which metrology is making a significant contribution to how that works.
Absolutely. When you let's touch on skill sets a little bit. So when you talk about skill sets, are you saying that it's harder to find people that can do these kind of complex operations, and that's driving a need for automation, or you need skills a skill set also to be able to handle the automation?
The skill sets from a operational perspective inside the manufacturing environment, you've got process engineers, manufacturing engineers, whereas typically in the past it was more on the quality side. This is now moving into the flow of the production. So those skills need to be in different locations now. It's the same people, similar skill sets, but they're just dispersed in a different way.
Okay, and I'm assuming also that when we're talking about kind of the benefit of an automation, one term that comes up is the kind of consistency and reliability of an operation. You kind of take the human element out of it, and so you would expect that your inspection or whatever process you're doing is going to be more consistent from shift to shift, day to day, so forth.
Yes, and maybe the best way to help define this inside of our organization, we have, let's say, 4 different levels of ways that we would customize a particular solution. We have an organization that deals this on a global basis, but say at the entry level, we have the ability to provide, say, parametric type programming or measurement routines, measurement plans for customers that buy our equipment. And then the second level, this is really taking it where we're providing fixtures, etc., into this particular process to load and unload. And you'll see some of this a little bit later as we get into further into the details here. You'll see maybe some video clips of how we do that. The third level is where we're looking by integrating sensor technology with third-party content, bringing that into an environment for metrology purposes. And this is where we bring in technology, we deploy it around the world into different applications, different industries. And then the fourth level, and we're going to go into some significant detail later on in this presentation, the discussion is really about our MMS strategy, and this is about data management. So this is going to be an exciting part of this discussion.
Okay, and the MMS is your metrology management
Correct.
system.
Yes,
absolutely.
Yes.
Is a metrology PLM that we're going to be discussing most probably later. We're very excited about that because, as Angus was saying, I mean, the opportunity in here is that you can deploy technologies, different carriers, different capabilities in a very tailored manner to the needs of a specific process, of a specific component, of a specific segment. And we can absolutely do that from a data gathering point of view, as Angus was saying, and we can do that from a data management point of view, which is the excitement we have in the MMS platform.
Okay. But the key point, I guess, just to add to that, Paolo, is this all ties together and it adds right from the initial point of starting to go through this measurement routines all the way to the end. And this is what Hexagon brings to the table here. We're uniquely positioned to be able to do this.
Okay, and I'm assuming all this is also what, shorter cycle times, right?
Yeah, absolutely. I mean, it fits the needs for shorter and shorter cycle times. It fits the need for different processes. And I mean, what we really, where we're really fitting into is the capability of adding value into different steps of a manufacturing process. And we do believe that we have automation solutions for really creating substantial value from the beginning to the end, starting with the design till the finishing, the inspection of the finished good, really.
Okay, and I know one of the things that I've heard from manufacturing people is that manufacturing's gotten much more efficient, and the ability to crank out parts is amazing. It's really fast, and now the bottleneck is the measurements. I mean, you can make stuff as fast as you want, but if you can't inspect it, even if you're sampling, if you can't inspect it to keep up with manufacturing, then your inspection department becomes your bottleneck. So speak to that a little bit.
Well, we absolutely see that as a critical challenge for us, the capability as productivity enhances to support that productivity from a quality inspection point of view. For certain industries, this is an absolutely top priority. Industries that are more exposed from a compliance point of view, we're discussing aerospace, we're discussing with key accounts in the medical world. They really want us to step up from this perspective. And this is where some of the technologies, again, that we are bringing to market in these last months can really make a difference from a supporting throughput point of view and from allowing quick data management, so delivering data in a very actionable way, so the decision making is enabled in a very fast manner.
Okay. Now, I think you, at this point, you guys wanted to talk about maybe, I think maybe we look at this kind of an evolution of automation. I think there were a couple different videos we wanted to look at, is that right?
Absolutely. Okay. If we look at the first video.
The first video is, I think, this is on the blade, right?
This is on the blade.
Okay.
This is a new technology that we have launched this week here in Las Vegas. And this technology is really allowing us to take data points at a substantially faster rate than ever before. It's a product whereby we can take a significant improvement to existing or conventional methodology of collecting data, in this case on blade inspection. And there's an example there on the video. And what you will see is, you can see we've got two different windows there on the screen. One is showing the conventional cycle time for measuring it in the historical methodology, and then over on the right, heat switches back and forth, but you will see then we're actually using the optical probe to be able to do this. And this is a fantastic major breakthrough for Hexagon, and the ability to be able to do this is going to be a game changer.
Now, is this a new probe we're looking at here?
Absolutely, yes,
okay.
The fiber optical probe.
Okay, so here we got an example. We're still looking at the blade here. So this is an example of just speeding up an operation that used to take how much longer before? How much have we speeded up with this new probe?
Well, it's largely dependent on the size of the product. In this case, okay. These are compressor blades, relatively small blades, and so the improvement in some cases is up to as much as 70% improvement. So it's quite substantial. Now, what does that do for the process? It's very, very attractive from the manufacturing perspective, because what happens is you've got equipment there, and you look at measurement. Is it really adding value into the production area? It's a necessary thing for us to have to do, is the metrology aspect of manufacturing. And in this case, these are inspecting blades which are 100% say inspection. So something that's safety critical, you want to get those products through the system as quickly as possible. If we look at, in comparison to the existing types of measurement methodology, what happens is the improvements that we've made have made the operation a little bit different, because the production people that were operating the measure machine could walk away because the cycle time was so long, and they could go and do another task.
Sure.
Now, the situation is we reduced that so significantly, so therefore, the next step for this really is to take it into automation by physically using a robot to actually load the measuring envelope of the CMM in this case.
Okay, and is it possible to, I think we have a video on that too, was it the 360 SIMS product?
No, that's going to come a little bit later, but
okay.
we have a video here just of pick and place. We've done this for
pick and place.
We've done this for many years. It's the ability to load, and in this particular instance here, we have an electrode that is being picked up by the robot and put into the measuring envelope of the machine. And you can see this is standard coming from a rack with many different components, loading the system. And this can be feedback into the machine tool as well. This is closing the loop. So this is something we've done for several years, but there's going to be more and more of a need for this. The faster the technology comes on the sensor technology, the way we speedily measure features needs more of this now, because it's a game changer.
So you're taking the human, again, you're taking kind of the human element out of even just the placement of the part.
Yes.
To speed up just, and if you're doing a lot of parts, I mean, that's incrementally, if you're saving a few seconds every part, then that certainly adds up over time, right?
Absolutely. I mean, it's about creating consistency in the inspection, and really trimming down to the latest second the possibility of executing those processes in the most efficient possible way. And this is a case that actually we have rolled out here in US, Angus, with a very large installed base. These technologies have been utilized, I would say, from the medical world to consumer electronics, in which, as you know, we're dealing with volumes that are extremely high. We have installations fully automated in the Asia Pacific world, for instance, and in which we really build substantial value.
Okay.
And I guess just to add to that, as the labor rate starts to increase in different parts of the world, to be competitive, what used to be an attractive proposition for, say, a Western manufacturer as now,
not so much anymore,
Exactly.
Not too much anymore, and therefore, this leads us, it all ties together, and as we get towards the end of the discussion and we talk more about the data management, you'll see why this is critical, because the ability to be able to move technology and equipment, technology, skill sets, etc., and to try and push that into the process. This is what we bring to the table. It's very unique, and so let's carry on.
Well, let's get into a little bit more. I mean, you've been in metrology for a long time. How many years have you been working in metrology?
Over 25 years.
Over 25 years.
Over 25
so
years.
you started when you were like 5, okay.
Yeah, exactly. You're actually 6.
So, I mean, how do you see these kind of changes impact metrology?
Well, we saw some examples there of just packaging together and automating the way that we're collecting data. The way that we do this is not only on small prismatic components like we saw in that video. Obviously, for an organization like Hexagon that has been in the automotive industry for so many years, we have systems whereby we can mount onto robots, we have sensors, different type of technology that is able to sort of do that, whether it be near line or in line, away from a production line for a vehicle going through. So we can apply that into different technologies. The changes that have gone inside of the aerospace business, carbon composite, different materials. People are looking at measuring things in a different way. So we have a video here which we're going to show you, which is our new 360-degree SIMS.
Okay.
And this is an inline system, and maybe Paolo, you can talk a little bit more about this video as we start to show this capability of what we're doing. This is just from one aspect to the other end of the spectrum, if you like. So.
Okay, and this is going to be the 360 SIMS we're going to see.
Yes.
Okay.
Yeah, absolutely. Dirk, we've been developing this solution together with some of our key partners from the automotive world. So we have data installations that, as we speak, have already been rolled out in the field. And the core of the offering in here is really to bring together quality inspection and process control in just one solution. It is fully automated in the production line for automotive. Key technologies, the capability with white light sensors to capture large styles of data with fairly high accuracy capabilities.
So this is a structured white light scanner on a robotic arm?
Absolutely. It is a specific version of it that really is tailored to the needs of the line, but it's a highly capable sensor that works pretty undisturbed from vibration, dirt, and different sources of light. So it is an extremely competitive offering here. When it comes to the integration with the line, the exciting piece is that by creating path optimization in terms of the robot movements here, we can really measure large numbers of features in very, very short cycle times. And then when it comes to the data handling, and here this is where MMS becomes exciting, the large quantity of data that is generated can be stored for future traceability, can be reported to different levels in the organization to allow for decision making. And this is where we can really bring a substantial contribution to the sector. Automotive inline inspection so far was more focused on the process monitoring rather than the quality inspection. So the parts were actually had to be confronted to benchmark with golden parts that had to be inspected with traditional and slower technology completely offline.
One thing that occurred to me watching this video here is you mentioned optimized paths for the robot, which is something a lot of people don't think about. Is even if you had a human being, I suppose, that was relatively inexpensive, and you were able to train them to go through it, they may not always take the most optimal path. Whereas with the robot and the right software, you always take the most efficient path through measuring the car, right?
It is a crucial piece of it, especially when you talk about optical technology, that in order to get to deliver the most accuracy, you need to be presented to features with a specific position. So we're talking about an optimized distance, an optimized angle of exposure, an optimized standoff. So this is really crucial. What's exciting in here is that we can inspect outer feature and internal features, and the whole car inspection can be reconstructed even for production lines in which several different vehicle types get manufactured just by reconstructing data through MMS.
Okay. So we talked a little bit. We talked a little bit about the data acquisition. Did we want to get into data management a little bit right now, or something else you wanted to hit on first?
Yes, I mean, just before we leave the point of the 360 SIMs, the ability to be able to piece together the data. I just heard Paolo say that, and when we measure vehicles in years gone by, we would take the vehicle away from the line, and there would be discrete measurements that were done. If there was a problem, you would go to a specific location, and then you might go and interrogate that particular area of a vehicle, whether it's gap and flush, etc. Well, the ability here, we can maybe go through and measure different parts of the vehicle in different cycle times. It depends on the throughput that's required, and then piece this together several minutes later, versus going to the quality room to go and do this separately and do a full inspection using conventional, say, horizontal arm technology. So this is a radical change.
Yeah, it allows you not to delay the decision in case your process is not delivering on the quality that you're really expecting. So you're anticipating, you're reducing eventually scrap, and this type of system also allows you, when you set a process up and running, well, to do that in a very short time frame. For automotive, for specific factories, that can be weeks until we have quality up to a level that we're comfortable with. And with 360 SIMs, we can really shorten that time to market and time to a quality that is in line with the expectation.
Okay.
So taking us into the data, we have products like Video of the Day, and this would be a short clip showing that, maybe like a thermal image of how the vehicle has changed over an 8-hour period. And then a management team could look at that and say, okay, I see what's going on, we have a trend of this, etc. So we're able to do all of that, all of those types of data.
Explain Video of the Day, because that was actually pretty interesting. From what I understand, that's actually kind of a time-lapse shot, if you will, of data throughout the
That's exactly
the
what it is.
Yeah.
It's over
like your color contour map, for instance, over the day.
Absolutely, Dirk. That's exactly what it's doing, and it allows you to be able to investigate where problems are, or if there's not a problem, you look at it, and within seconds you know that your process is under control.
Yeah. And then I think, Angus, for your large installed base in aerospace here in US, we're talking about automotive here, but this is a pretty flexible set of capabilities that can be deployed in different segments, I believe.
Yes, absolutely.
Okay. Let's go ahead and switch gears a little bit, maybe, and get into the data management. Does that work? Okay,
yes,
sure.
Yes.
So what do we mean by data management in terms of metrology? I mean,
well, obviously, metrology is in the business of generating and distributing data about the quality characteristics of a component, of a subassembly, of a feature, of a finished product.
And not just the characteristics, are we talking sometimes even the entire point cloud data? I mean,
Absolutely.
Including that as well, not just the results, right?
Absolutely.
Okay.
Absolutely.
Yes.
Now, when it comes to increasingly amounts of data that get generated, the capability of storing that data and then making intelligent decisions on it is really a crucial capability. What we wanted to really make use of is platforms that we have in the group. Let's think about Smart Plan Foundation, which is a PLM that is widely utilized for the oil and gas industry, for the process and marine industries. Well, architectures of that kind give the opportunity of storing incredible complex amounts of data. So what we are deploying with our key accounts today, as we speak, is a metrology PLM that allows not only to do that, so allow for traceability of quality data, but also to build on top of that modules with characteristics that can be, with functionalities that can be extremely interesting for many different segments. Let's talk about, for instance, virtual assembly, okay? So for industries that have very complex supply chains, if we talk about airframes, the supply chains that are spread through countries with elements of fuselage or components that come together from many different factories. The fact of having a virtual assembly module that allows you to compile data that comes from maybe laser sources to inspect those components, where they get manufactured, before they actually get installed and assembled. Well, that allows you to find non-compliance well in advance, and then to ease the assembly process as it happens. Statistical process control can be another example of that, for instance.
And it's not just even, typically when you think of virtual assembly, you think of something, whether it be an automobile or an aircraft, but it can actually be other components where they're made in different, not even different countries, but different continents. For example, even the electronics sector, this is quite common, molding somewhere or, different materials somewhere else, piecing together and bringing that together. And if you're about to ship, 100,000 or 100 million components, you would like to know whether that's going to assemble at the right location. So this is the direction that the industry is demanding, that somebody like Hexagon is able to sort of accommodate those industry needs.
Right, and we're getting short on time here, and there's a couple other points I want to get to, but did you want to touch a little bit on your MMS?
Yes.
Okay.
Yeah. If we look at the dashboard of MMS, the ability for a OEM to be able to look at all of their supply chain, to be able to look at what is going on with the metrology, the use of metrology equipment in different supply chain, say, vendors around the world, to be able to feed back, to be able to watch, and if you need to redeploy some particular task or operation to another part of the world, etc., or another country, another supplier, the ability to do that or look at one supplier versus the other for efficiency purposes, this is what this product is about.
So this, and if I understand correctly, one of the key components of MMS is the ability to read from individual, let's say, measurement machines, status and actual measurement data and so forth, and like you said, report them back up to the dashboard, right?
Yeah, capability.
Okay.
Yeah.
And from that you can, operational efficiency, predictive maintenance, I'm assuming perhaps,
Absolutely.
that sort of thing?
Absolutely.
Exactly, for diagnostics, to be able to do that too.
Absolutely.
Okay.
MMS combines a set of capabilities that really can be relevant to various segments. We're talking about the assembly of large parts in the case of virtual assembly. If you're now more looking at industries that have a very quick cycle time, where a lot of changes are needed, we have change management tools that really allow to create measurement plans every single time that CAD designs get modified. That creation of measurement plans will be fully automatic, and we're really allowed to deploy quality as changes occur. We have modules in terms of asset management that can be very relevant for manufacturers that have wide installed base, where there's a high level of sophistication from a production point of view in terms of getting the most out of your assets. But then when it comes to metrology, asset utilization tools allow us to optimize the flow of goods and components through CMMs, arms, trackers, whatever kind of carrier we want to deploy, to make sure that uptime gets maximized and throughput through inspection devices get optimized.
How much of an investment do you see your customers making in automation, and where would those investments be?
Well, we see it dramatically increasing. It is the case when it comes to traditionally established industries, when it comes to obviously powertrain, for instance, where automation is part of those processes since quite a long time. We see the capability of consumer electronic industries, fast voluming, large volume of production. We see them investing more and more into that. We see investments in automation happening offline, for instance, where despite cycle time not being as constraining, there's a clear benefit in streamlining and standardizing quality, even if in offline setting.
How important is it? How important is the metrology partner in automation? It's kind of a leading question, but how important is that? I mean, what should people look for if they're going to be getting into automation? What's important in this?
I think the important change for us is in days gone by, where quality was typically towards the end of the process, and also was usually at the end of the buying cycle when a new program was going to be started. Now, because it's really embedded into that process, we're more involved at the early part in the design of a new program for whether it be a vehicle, etc., or aircraft. We're further and further into the manufacturing process than we've ever been before.
Okay. Well, Paolo and Angus, really appreciate you being with us.
Wonderful. Thank you very much.
Very interesting, actually, to really broaden the view of automation. We've gone from something that's just kind of machine-centric to something that really propagates through the entire process from design, design to the end.
Exactly.
PLM, right? And this is what we're talking about.
That's what it is.
Absolutely.
Okay, well, gentlemen, thank you for joining us on the show, and thanks to all of you for joining us on HxGN Live 2014 Executive Edition. I'm Dirk Dusharme. This has been Paolo Guglielmini, Angus Taylor, and we hope you will join us for the next HxGN Live.
Well, there you have it. Again, that was our own Dirk Dusharme with Angus Taylor, President and CEO of Hexagon Metrology North America, and Paolo Guglielmini, Director of Business Development for Hexagon Metrology. They were talking about automation metrology. Really interesting, good discussion with those two folks, with Dirk. So good stuff there. And again, we captured that at HxGN Live back in June, and HxGN Live next June will be another great one to look forward to. Another good thing to look forward to coming up next month, or early next month, starting on September 8th, is IMTS. Hexagon will be at IMTS, of course, in booth E5202. They will have 2 automated data cells there at the show in E5202, one on white light and one on laser-guided laser tracker. So check that out. Again, if you're going to Chicago next month for IMTS, be sure to stop by and see us, and of course stop by and see Hexagon again in E5202 as well. Okay, well, that's our show for the week, but before we go, we'd like to thank today's sponsor, 360 Performance Circle, a new kind of training company with handsomely produced streaming video content covering lean, quality, and best practices within test and measurement. 360 Performance Circle is your destination point for the best training on the web. For more information, check out the banner ad just below or just to the right of this video player screen. And speaking of 360 Performance Circle, also be on the lookout for an invitation to a webinar about 5S and Lean coming from them and Lean trainer Mike Mickelwright. The webinar happens, as you can see on the screen right there, this coming Tuesday at 2 p.m. Eastern, 11 a.m. Pacific. So check your inbox for more information on that webinar. Stop half-essing it. Don't do just 2 or 3 of the S's and 5S. Do all 5 of them. That webinar is going to show you how, so check your inbox for more information as well as details on how to register. Okay, well, that's it for this week. Thank you all again for joining us. Dirk back next week. You can look forward to seeing him. Of course, the webinar on Tuesday. Thank you all for being here. Thank you to Hexagon for a great segment there from HxGN Live. You all have a great weekend, and we'll see you next week.
Thank you.